Well, I will start with a quote, a memory from the days when I was a student, and I was sitting in an electronics lab in front of an oscilloscope, and there was some device which sent us an HF signal, and the instructor said, okay, this is the oscilloscope, you take it, you push every button, you turn every knob, you do all the control functions you can imagine, try out everything, see what you get, and I hope you will understand it. And it's a bit the same with the eScience Center. What I will do, and what you also should do, is some sort of just go in and explore it. And don't be afraid. If you rest here with the first line, which is this above, you cannot do anything wrong. You cannot destroy the eScience Center, explode it. Just play around and see what we'll do. And that's what I will also do, a little guided. Before I come to the data access, well, I start from the right to the left. It's unusual in the European way. I want to spend a few words on the ontology. The ontology is a collection, I would say a tree of terms which are defined, and the interaction between these terms is defined, and these are guiding the search functions in the end. And there's many entries here. Some are particularly interesting, for instance, data level. Here in the project, we have some data levels, level 0, 1, with sublevels 2 and 3, and there is a description, a definition of what these data levels mean, because not all data providers all over the world use the same definition for data levels. So this is what is used here. This was under data levels. Then there is a data quality flag. This is a similar thing. There are certain categories for data quality which are defined in the eScience Center, and these are the ones that you will find throughout. And this is not always identical to those what individual data providers use as data quality flags. Then there are some terms which we need to understand. Feature of interest. What is meant by feature of interest? And you see here, well, for asteroid, we have no data entry. But for Earth, for example, Thomas showed it already, the Earth is a feature of interest. But within the Earth, there are other features of interest. For instance, the atmosphere, ionosphere, magnetosphere. In the ionosphere, we have again a subset of features of interest, D region, E region, F region. In the E region, we have still a subset of entries of E layers. Unfortunately, at the moment, if you go to details for E layer, for instance, you see definition is none. That is not ideal. There should be something. And in particular for an ignorant like me, for instance, who did not know what an EA layer is, and you had to ask Ivan for this. If I open details, there is no definition. So if you do not know what an EA layer is, at the moment you do not find it from here. But I hope we will improve this, because this is work in progress here. We are in the middle of the project, and if everything would be in, then Thomas would not know what to do the next 2 years.
Please always send these kind of requests to us, because we have no idea.
No, it's not your fault. I mean, it's a data provider.
No, I know, but not necessarily. So we really need to know.
You online. You must
sorry.
The microphone.
Just.
Okay. And so this to the feature of interest. Another thing that you will come across and what you need to know is what is meant by observed property. For instance, if you're an ionospheric physicist, the critical frequency is something that you're often interested in. And let's say you are interested in the critical frequency of the ordinary mode. That would be this here. And then you have the E layer, ordinary critical frequency, and the E2 and the F1 layer, ordinary critical frequency, and the F2 layer, ordinary critical frequency. So these are all these observed properties. So so far to the space physics ontology. Browse metadata. Well, catalog we don't have. Thomas said that we have metadata, but we have no data, so I skip this. And here you have certain data collections, organizations, which is to tell you which organizations are there. Centre National de CNES, you have a brief description of what is in, what it means, and so on. There are then some others which are, I find quite interesting, acquisition capabilities. That tells you what capabilities one has to get data. And for instance, an interesting thing which is involves more than one data provider is this here, D2D, Digizond to Digizond sky mapping. And that is explained here what it means. You need two Digizonds at different places, and you make a synchronized pulse from one to the other, and analyze this, observe this, and analyze this. And under the acquisitions, that is for the moment a little difficult. There is from the TechTide project this D2D SkyMap acquisition, but the data collections of those, or catalogs of those which was created in TechTide, they are not yet available here. But that was done and proven that it works in the TechTide project. So far about metadata, browse catalogs. Well, this is only the metadata of the catalog, so there's nothing in. Now browse data collections, Thomas said. Now we have only a few, so we can easily go through. Look, for instance, TechTide activity index, what it is. We find it here in the TechTide warning centers tab. Well, it takes a moment. Can look at indicators. Can look at LSTID over, I forgot I should increase the font here for the, I heard that those here who are on Zoom, they have less resolution there. So you can see here the LSTID, the variation for different stations. Now, well, I will come to the search data collections. Let's say you are interested in the critical frequency. Well, maybe I should. Is anybody on Zoom here? Is this, the resolution good enough? No? Okay. Let's see, I can make it. Because I was yesterday talking to somebody who said those what is taken from the camera does not appear well on the Zoom, it is blurred. But what is already displayed on the Zoom is also seen very well by the others on the Zoom. Can you confirm this, Thomas?
Yeah, the Zoom is not readable, so nothing is readable if you are on Zoom.
Okay.
You can't see the slides.
So I hope this is now zoomed in enough so that one can see it. We have seen this already. One can go Earth, ionosphere, and so on. One can also do a search. Let's say start a search. So I said I'm interested in the critical frequency. Now I'm here in the main entry, features of interest. Is critical frequency a feature of interest? I explained it in the ontology, but I have forgotten it. Okay, so I just do a search. No? So what do I see? Nothing. So obviously, features of interest was not the right thing to search. Let's say I go to observed properties, and I try, no, sorry. And I look at here, yes. And there I have an entry, wave, and there's critical frequency. And there I can again say, okay, I'm interested in the O mode frequency, in the, for instance, in the E layer, in the F2 layer, in the ES layer, and I search. And this gives me now a list of data collections where I can find data where those layers which I selected, where they are displayed. Let's take, for instance, the DID base. Don't care, don't mind this login, it has nothing to do. There is one entry where you can have images of the ionograms. It did not work until 1 hour ago, but now it seems to work. So we do this, the ID base. We use a station list from the use a station from the station list. Now here it's alphabetic. I made it alphabetic. Let's say we are using the rocket. That is an ionosonde operated by the Observatory of Ebro in Spain. Use this. Then I take the year 2002, January 15. That was the day of the Tonga earthquake. But this is a data collection. It's not related just because we talked about the day I take this. So I take, for instance, that was around, I don't remember, around 14 hours. Go on this. And I get here the image of the ionogram that were taken at that moment on January 15 at the rocket's station. And so I can go to the next ionogram if I want. And I can continue like this. You see, I think every 5 minutes, there's every 5 minutes an ionogram. So far for the imaging, but there is also the way to get a text in plain ASCII. I take the same time interval, 2022, January 15:00. Make the stop date the same, add 1 day to it, take again the rocket station, and do a search. No, I have to select what I want to have. So otherwise, I want to have the F2 critical frequency, let's say the E layer and the sporadic E layer critical frequency. And then I do the search. And then you see what, well, in some respect you would expect. It starts at the night time, you have an FO2 critical frequency, but no sporadic E and no E, because we are at night time. Then when you go further on, you have here the full day of ionograms at about 7:30 in the morning. Signals from the E layer come in, and then occasionally you have a sporadic E layer here. And then when it goes back to night, again, there's only the F layer. So here you have the data in numerical format, those that you would normally want to use if you use some quantitative analysis. let's take another of these links that were provided. For instance, the NOAA Athens Digisonde, that are data from exactly this Digisonde. Well, it takes a while. Okay, it's there. As again, starts with a description, and then here you have, well, I think it can be an API. API, yes. I always had problems with the API. Did it work for you before?
It's not the Science Center, so I never. Is it? No, it's not the Science Center.
Yeah.
Exactly. So I have never tried.
Okay, that is not only now. I had this problem before with the API, but others would work, no? For instance, here you have now images of the ionograms, of the sky map, of the velocity, and so things from this particular ionosonde, the Athens ionosonde. And this, DID, we have seen this before, the web portal. So you could also look for other, for the measurand, for instance. I did not explain the measurand before, but the measurand is neither the observed property. For instance, the observed property would be the E-layer critical frequency. The measurand is frequency, just frequency, without attached to any particular feature of interest or any particular phenomenon or so. Frequency, like here. And under frequency, you could then select several things, like, for instance, the critical frequency. And do a search, and again, you get models as well as databases, and no surprise, it is to some extent the same database. And that is due to the fact that so far those who operate ionosondes were also those who were the most ready and keenest people to registrate their data. So, okay, I stop with this and repeat only my phrase from the start. Go into it without fear, play around, search, and see what you get. Thank you. Okay, if there are questions, I'm not sure if I am the best to answer questions, but we have several might try. Because I'm none of the data or model providers for this. I'm just a user, potential user.
So any questions to Jurgen? Either here or online? Okay, so then thank you very much. So then the next presentation will be by Sean, and he's going to show a module from the Science Center. Just in the kind of switchover time, one thing is that as most of you start using the Science Center, please always take the time to let us know if something is wrong. Okay, so we will not, we cannot check it like every day, and we cannot check every single functionality. Most of the things are created in the Science Center automatically. We never put it there. So that means that we need to kind of know if something is not working properly, because the testing now becoming so tedious that we cannot test for the functionality. The other thing, not only if not working, but if something annoys you. Yeah? So if something says that it is not like I would like to see, or the data is not there what I'm looking for. I think that would be quite important for us to know. So always please take the time. There will be a ticketing system soon. At the moment we don't have that, so just drop me an email and then we are going to have a look at it.
Well, I would like to add something which I learned especially this morning, if there's something not going, do not ask first, it's the eScience Center. Ask first if the data provider is the source of the error.
Yes, that is also a possibility. At least we can assess that where the problem is coming from. So we can say to you, no, we can't do anything with this because this is the data provider's problem. Or we can say, yeah, so for example, this one which you just spotted, I now kind of had a look at this, and I think what you would like to see is the definition.
Yes.
Yeah, and that is the, well, I can just blame Ivan in this particular case, and which is not very nice. But obviously he's quite busy. So when he put it in, he just did not put the definitions into the ontology. It can be done any time. Somebody needs to take the time to put all nice definitions there. But we just show what is currently there.
I don't know. There we go. Okay, good morning. So I will give a short demonstration. I only have 15 minutes, so necessarily it will be a demonstration of a very simple model. It's going to be an empirical thermosphere model, DTM 2020. So you can reach that if you go to the browse data. You see it sitting about at the top. So this is an empirical thermosphere model. Normally it is...
Could you zoom in because the...
I cannot, well...
Yeah, Control plus.
Yeah. Control plus. Where the fuck is the plus? Huh? Command plus.
Well, I make it at 200%.
Yeah, but well... Anyway. Okay. What kind of weird Zoom link is this? Normally you have exactly the screen.
It's not just a Zoom, it's just from here in the room, it's not so easy to read.
Sit in front. I don't know, because I can't see my own screen anymore. So, so this is an empirical thermosphere model that computes densities pointwise. So for any date and condition position, you give one density. So that is not what is done here. What we've done so far, what you can do with the model is described under procedure. So what was done now is you can select conditions, altitude, and for this specified altitude, you get 2D maps, latitude versus local time. So you get densities or composition temperature at a specific selected altitude. So this is one of the models that is accessible through an API. This is the API that is generated automatically through the eScience Center. So it's not optimized for DTM. This is a general layout of this automatically generated API. So you can run this model in this way. You have at the top, you have execute. There's an explanation given of the parameters that you have to fill out in this next couple of lines. You have to fill out the solar and geometric activity conditions. So flux, so let's change this to something like 200. Daily flux, we'll say it's the same. Let's take an altitude where most Earth observation satellites sit, like 800 kilometers. Day of year, 180. AKP, so that's the KP that is described at the top. So take 1. At the bottom, I'm going to make a mistake. 11. It will tell you if you had read the instruction that you cannot go beyond 9. So okay, let's correct this into 1. Execute again. So now we have the information here. Let's say synthesis of the run. It gives you the execution ID, which you need for the following steps if you want to plot and download this information. And it gives you the parameters that you used for this run. You can download this if you want to remember later on what kind of computation you exactly did. So you can download this. It ends up in your this, of course, I suppose you cannot read anymore, but so this is in the editor, you get your information. Okay, this was your run, this was your, these are the parameters you selected. Something that is not intuitive, so if you're going to go to the next instruction, you have to hide the details again. So now I want to plot. Here I need to give this execution ID, so that was the number that was just given for this specific run. And let's say I want to plot density row. Run the plot. It shows up on screen. It's not very, very nice for the moment. I don't know what is going on with my... It's cut off. So what you see here is the latitude versus longitude for density and local time. So we have from pole to pole and from 0 to 24 hours. You can take any of these composition and temperature. If you switch to temperature, you get a new plot. You see here, we chose day 180, so that's northern hemisphere summer. So we see that density was maximized in the northern hemisphere, temperature maximized in the northern hemisphere. Then we have the files. So if you say, well, one of these files is, one of these outputs is only interesting to me. I was only interested actually in this temperature that I just showed. Well, okay, in that case, you can download this single file for a single output, so a temperature or a composition. So that is how you run the model. So now, run it for a different situation. We can run it now for what we just did was high solar activity. Now let's do it for same conditions except solar minimum conditions. So I'm putting in solar flux 70. I execute it again. I get a new execution ID with my parameters. I can download this again so that I remember what I did. I have to hide the details again. Now I can plot this again. Starting out with temperature again. So we were at 1500. So now we're dropping to 850 because we're going to low solar activity. So that's one of the consequences, of course. And let's plot density again. So this is what you see now. So now we have density. Typically, during low solar activity, we have the helium bulge. So we actually have our density maximum sitting in the opposite hemisphere. Our density maximum is in the winter hemisphere. So if you want to say, okay, that's strange, I didn't think of that. I actually want to have all the information. Where does this come from? How is it that, I just told you it was the helium bulge, but suppose you don't know. You can go to results. And if you go to results, you run that. It will create a zip file. For the moment, it's still under construction, so you have to manually rename it the zip file, but you can download this file with all the results, so the plots and the data files. So this is what will be cosmetically improved in the near future. So let's call this low flux zip or something. Okay. And now you have, in your dossier, you have all the information of this particular of the low solar activity. So you have all your plots. So here you see now, it is indeed helium that maximizes in the southern hemisphere. If I'm looking at the oxygen, it has their usual behavior. It maximizes in the southern hemisphere. So it helps you understand. And now you realize, well, it was actually, maybe I should have, knowing this, I should have saved my first run, downloaded all the results as well. Well, you still can. because we have, of course, still the runtime number. So if I go back to the run just before, so I go back to this old previous run, I take the previous run, I get a new download file, and again, of course I have to, change this again in a zip file. So call this this was the high flux. And so now I have my two folders, one with my low flux results, one with my high flux results. So as long as you keep a list of your run IDs, you can always go back to your former runs during the same session and retrieve stuff. So if you said, I was only interested in temperature or density, and later on said, well, I should have retrieved helium as well, then you can. So it is a work in progress. Like there are still some cosmetic glitches, and there is still a little bit of information that is not as obvious as it should be. The fact that really make clear that for the moment you have to rename it a zip file. So that is all a consequence of using this automatically generated API. So it's something, the API is generated automatically, so that part is very easy, but that brings with it a certain number of limitations like this. But so Thomas is working around this, trying to solve this so that we got readable names and understandable file names. So that's it for the simple demonstration.
Thank you very much. And just before the questions, a couple of comments. So one thing which is very important, which you mentioned, is that because thanks to you, once these issues are sorted out for your model, they will be sorted out for every model. Okay? So this is not a solution which we are doing for you. These file names, if you solve these file names, then every other model which uses a zip, the problem will be solved. Right. So that is one issue. The other issue which Anna raised yesterday, and if you go, could you please go to the run or execute menu for a second? Because I would like to show something there. Because this very specifically came up yesterday. So in this one, in this case, we've specified numbers like the integers and so on. But obviously, exactly the same solution works if your model takes a huge input file from somewhere, okay? So if you got a terabyte input and your model is capable to work on that, then we are going to generate you exactly the same kind of box where you type in or copy and paste in the URL of the data source, and then that will be the parameter. So it is not restricted to small input values. We can take from a data source, if your model knows how to access that data source. Okay? If your model is written in a way that your data source can be given as a parameter, then again, we can just take the name of that data source and then fantastic, the model connects to that one. So there are no limitations from our side. Obviously, there could be limitations from the model side. So if somebody 20 years ago written the model and hard-coded that this model takes data from there, we can't change that. Unless somebody goes into the code and changes how the model is written. So that is not under, we can't do that, okay? But if the model is written flexibly, then we can show, so it may require, and I think that is the message which tomorrow I'm also going to tell, this may require your team who developed the model to re-engineer the model, to be more flexible if it is not good enough, in order to improve the availability of that. So, yeah, any questions? Sorry for
I ask because I'm concerning of the computing and storage you running for. Do you see this a normal model? I'm in terms of computing consumption and the storage consumption data for future model also in this scale, or there can be more. Model consuming
this model essentially uses nothing at all. Like the CPU time is negligible. It's a statistical model that you give you give environmental conditions, and it gives you the prediction for that specific set of parameters. same thing like Thomas said, if you could do that like for a whole suite of conditions and run this in a chain, but this is a very, very light model. It's not a numerical weather model or something. This essentially costs nothing, and the output is just like the grids I showed, such a 2D grid.
So just from a technical point of view, this runs on a virtual machine on EGI. That virtual machine has certain storage capacity. So what we do is that after a while, we automatically delete all the results. So Sean showed that he just copied the execution ID. Yeah. That execution ID will not be stored forever. Okay, so we are going to, we could, if we can have storage capacity increasing, but at the moment I think Dimitris is set is something, so after a month or something like that, it will be automatically deleted, so that if in a month you would like to come back to that execution, that may not be available.
These are grids like they're tens of K, like it's...
Just because what I concern is the increasing of the capacity in future. When there are more model, more data set, what do you expect in the...
Well, I don't know. It depends, because I have no idea how many people would like to execute their models on EGI. Until now, I learned that with the exception of Sean, nobody is going to do this, because everybody else is going to execute the model in their institution. This was what most people told me. Sean was the only one who said he cannot, because if it is executed inside, he cannot give access to this.
The bigger models run at the Virtual Space Weather Modeling Center, and so they have their own ticketing system. So they know how to handle large amounts of requests and data. Actually, this model also runs at the VCMWC, so it runs on both sides. But there's an older version on the Virtual Space Weather, DTM 2013, and the newer one is here. But they're both like entirely negligible in use of resources.
But actually, that's a very good point, that is again something which we need to know from the providers. Who is planning to run it on EGI, who is not planning to run it on EGI. Until now, my understanding was from the questionnaires that practically nobody wanted to run the model on EGI. But again, I may not have the... I think people just starting to understand what it means, so I think we will probably need some more time.
Can we just clarify how long these IDs persist for? Because you said it remains during a session. You said it might stay there for a month. Do they persist? Are they shareable with other people? I mean, how are they dealt with?
Yeah, at the moment they are. So I'm not sure whether we are actually deleting or not deleting it, but this is really up to the model provider. So if they tell us what to do with this, we can keep it forever until EGI's storage capacity is exhausted. Exactly.
If you want to share it, someone who did a run could just send you.
Yes, exactly.
Yeah, they're not tied to that particular.
Send you this
session.
file.
They are not tied to the browser. No.
Yeah, I mean,
It's not executed in the browser. It's executed on the server, and on the server we are storing all these IDs. Until we again, I think my colleague set it to a certain time because we discussed it, and I said, well, there is not too much point to storing it forever. So at the moment, just delete it when kind of time comes. So let's say in a month or in half a year, or I don't know. But it's really nothing. So we can it's up to request.
it's a technical question. Why go for virtual machine and not something like a Lambda function, which would be scalable?
Because
such a lightweight model?
because EGI hasn't got Lambda function. So EGI can give us the resource provider can give us a virtual machine, and that's it. But they can give us very big virtual machine if you want. But they don't have serverless functions.